This video will cover intermolecular forces, which are forces between neighboring particles and phases of matter. You should have already learned about intramolecular forces, but you probably didn't know that's what you were studying. Intramolecular forces are forces within molecules. So if you have drawn a Lewis structure, you are drawing intramolecular forces or bonds. We will talk more about the differences between intermolecular forces and intramolecular forces later on in this video. First, why do intermolecular forces exist? The reason is because opposite charges attract, which can be quantified in Coulomb's law. Coulomb's law states that the force between particles is a product of a constant times the charges of the two particles divided by the radius squared. Since everything tends toward lower energy, a negative force is more desirable. A negative force will be obtained when the particles are of opposite charge. If the particles are the same charge, a positive force will be obtained, because two like charges multiplied together equal positive. First, let's talk about phases of matter. There are three phases of matter that are typically covered in chemistry classes, and you have had experience with all of these. They are solid, liquid, and gas. The differences in these phases of matter are their density, compressibility, shape, and intermolecular forces. Solids have high density. They are not compressible. Can you compress a rock? No. They have a definite shape, and they have high intermolecular forces. Liquids also have high density, but most liquids have a lower density than solids. An exception to this is water, which causes water to have lots of interesting properties. We will discuss these properties in the intermolecular forces problem video. Liquids are not compressible. They have an indefinite shape because you can change their shape by pouring from one container to another. And they have high to middle intermolecular forces. Gases have low density. They are compressible. Ever fill a tire with air? They have an indefinite shape, and they have low intermolecular forces. The first type of intermolecular force we will be discussing are the weakest ones, London dispersion forces. They are named after Fritz London, a Jewish German physicist, whose work on chemical bonding and intermolecular forces are considered to be classic and are discussed in nearly all chemistry textbooks. And don't let the name fool you. London dispersion forces are not about dispersing molecules. They are about holding molecules together. Even though London dispersion forces are weak, they are between every molecule and atom. This is because they are caused by temporary rearrangements of electrons, called temporary dipoles. In a certain moment, when two molecules or atoms approach each other, their electrons can rearrange so one side of the molecule or atom is more negative. Then the more negative side of the molecule or atom can cause another molecule or atom to also rearrange its electrons. So one atom's negative electrons are attracted to another atom's positive nucleus. The strength of the London dispersion forces increase as the number of electrons increase, because they are more likely to be distributed unevenly or polarized. London dispersion forces become stronger as the molecules become larger and have greater polarizability. They are also stronger as the molecules become less compact. So therefore, molecules that have a straight chain shape, such as pentane, have stronger London dispersion forces than ones that have a smaller surface area to volume ratio, such as 2,2-dimethylpropane. Pause the video now and count the number of carbons and hydrogens for these molecules. You will see that they are the same. This is because these molecules are isomers. The next type of intermolecular forces we will consider involve only polar molecules. Polar molecules are ones that have unequal charge distribution. Polar molecules contain atoms with different electronegativities. The weakest of these intermolecular forces is dipole-dipole interactions, and they involve molecules with permanent dipoles, or partial charges. Dipole-dipole interactions happen when the partially positive side of one molecule is attracted with the partially negative side of another molecule. Since these dipoles are permanent, these interactions are substantially stronger than London dispersion forces, which involve temporary dipoles. Another type of intermolecular force that involves polar molecules is ion-dipole interactions. These interactions involve an ion, which has had an electron removed or added, as well as a polar molecule. These type of forces are stronger than dipole-dipole interactions because they involve an ion. Ion-dipole interactions are how salt dissolves in water. The water molecules pull the ions from the solid into the solution. When an ion is surrounded by a ring of water molecules, it is surrounded by the sphere of hydration. The strongest type of intermolecular forces that involve polar molecules are hydrogen bonds. Don't let this name confuse you. Bonds typically implies within a molecule, but hydrogen bonds are between neighboring molecules. They are a special type of dipole-dipole interaction. Hydrogen bonds form when hydrogen is covalently bonded to a nitrogen, oxygen, or fluorine atom. The reason this type of interaction is special is because nitrogen, oxygen, and fluorine are small electronegative atoms. Let's show you an example with water. When any one of these molecules are bounded to a hydrogen, they will take most of hydrogen's electron density, which will leave hydrogen very electron deficient, or partially positive. When hydrogens, which are attached to a nitrogen, oxygen, or fluorine, encounter any one of the three attached to a hydrogen, the partially positive hydrogen is highly attracted to the small electronegative atom. Therefore, they can get close. Hydrogen bonding is very important in DNA molecules because they hold together the two helices of the double-sided helix. but hydrogen bonding is only an intermolecular force, not a much stronger intramolecular force. So they can be broken, which happens every time DNA is replicated. The difference between intermolecular forces and intramolecular forces is that intermolecular forces are much weaker because they are between neighboring molecules. Intramolecular forces are bonds between atoms to make a molecule. They are bonds within a molecule. Intramolecular forces are stronger because it takes more energy to break a bond within a molecule than it does to break an interaction between neighboring molecules. Covalent and ionic bonds are both examples of intramolecular forces. Ionic bonding is also referred to as an intermolecular force. However, because when ions come together to form an ionic compound, there are many ions that come together. The order of strength in intermolecular and intramolecular forces is from weakest to strongest. London dispersion forces, dipole-dipole interactions, ion-dipole interactions, hydrogen bonds, covalent bonding, ionic bonding. The reason we know this is because melting point and boiling point increase as the strength between neighboring molecules or atoms increases. Please watch the next video for problems relating to intermolecular forces.